Assalamualaikum, greetings. In previous video, we already cover question A, B, C, and now for this video, we're going to discuss question D. Right, the aim of question D is we're going to outline the stepwise mechanism. Okay, remember, this question is different from the synthetic sequences. Synthetic sequences is referring to the production of the benzene derivative, while for the mechanism, we are focusing on the electron, we are referring to the process which happens during the reaction. Okay, so the question was outline the stepwise mechanism for reaction between benzene with reagent 2. So we already determined that reagent 2 is from the Fourier-Kraft alkylation, which comprises of the addition of CHCl catalyzed with AlCl3. Okay, for this mechanism, we need to show how does the CH3 is replacing the hydrogen from the benzene ring. In this case, if you number the benzene ring, okay, it replaces the hydrogen from carbon number 1. For the mechanism, you need to show three things. Okay, the first one is the generation of electrophile. Okay, after all, the name of the mechanism is electrophilic substitution reaction. Number 2 is the replacement of hydrogen from the benzene ring. The third one will be the regeneration of the catalyst. So let's take a look at the mechanism. First and foremost, let's go for the first step, which is the generation of electrophile. So we already knew that the structure is benzene. Then we add CH3Cl catalyzed with AlCl3 to produce methyl benzene and the side product of HCl. Again, the H is coming out from the benzene ring, while the Cl coming out from the Fourier-Kraft alkylation reagent. So based from here, we need to show first how does the electrophile is being generated. So the electrophile can be generated from the reaction between these two catalysts and also the reagent. CH3Cl, and then we add AlCl3. So what's going to happen is the Cl will be attracted to the AlCl3 to form the AlCl4. Since there is excessive electron at the AlCl3, so this will produce a nucleophile. It has more negative charge. For the CH3, since the bonding between the CH3Cl has been broken and then the electron will move to the Cl, it will only left the CH3 act as the electrophile. Remember guys, electrophile is species which attracted to electron. That's why the charge will be positive. This will be the first step. In another example, if we are dealing with the nitration, the reagent that we use will be nitric acid and the catalyst will be sulfuric acid. So the addition between these two, we know that it will produce NO2 plus as the electrophile, and then the side product will be HSO4 as the nucleophile, negatively charged, and the other one will be the production of water molecules. For halogenation, let's say we have chlorine, which will react with iron chloride. One of the chlorine molecule will transfer to the iron chloride to produce a nucleophile of FeCl4 negative, and then the electrophile is being generated will be Cl plus. Okay, please check with the free radical alkylation and free radical acylation and determine which of the species becoming the electrophile. Since we are discussing about the free radical alkylation, okay, we can ignore the first two, and this will be the first step, which is the generation of electrophile. Next, the next step is the replacement of hydrogen from the benzene. So, after we have generated the electrophile, which is CH3 plus, okay, remember, don't forget the symbol, we're going to attack the hydrogen from the benzene ring. So we have 6 options, okay, however, I would like to highlight hydrogen at the top. So what's going to happen is, if we number the benzene ring, it will comprise of 6 carbon. The CH3 will replace the hydrogen from the first carbon. So what's going to happen is, the double bond between the carbon number 1 and number 6 will be broken. So the electron here is comprised of 2 electrons. What's going to happen next will be, the double bond between number 2 and number 3 and also number 4 and number 5 will remain, while number 6 has been broken with number 1 to attach to the CH3, and of course there is the hydrogen that we're going to replace. Since carbon number 6 have losses its electron, what's going to happen is, okay, it will bear the positive charge. This process, the positive charge will attract another pi electron from carbon number 4 and number 5, because it is also comprises of 2 electrons. So 4 number and number 5 will attract to carbon number 6. So if we draw back the structure, it will be looking like this. Number 2, number 3 will be remain the same. And okay, first we draw the hydrogen and also the CH3. Now the new double bond will exist at carbon number 5 and number 6. Because just now again, the electron from number 4 and number 5 has attracted to carbon number 6. And then carbon number 4, losing its electron, it then will become positive. And we're going to repeat to the process with carbon number 2 and carbon number 3. Since the pi bond is consists of electron, it will attract to the nearby positive charge. So if we draw back the structure, it will be looking like this. This is H, this is the CH3. This is the newly formed double bond. And then carbon number 3 and number 4 will have the double bond because it's attracted to the positive charge right now. Carbon number 2, losing its electron, will produce a positive charge inside the ring. So as you can see here, the positive charge inside of the ring is being circulated. So in general, we can draw the structure like this. Okay, we have the H and then we have the CH3. Then the charge of the positive is being delocalized inside the ring. This is the stabilized structure of the product of the benzene produced, of the benzene derivative. Okay, and finally, what's going to happen is, we just take the structure of A right now, we draw it back again. Okay, carbon number 2 and number 3, and also we have carbon number 4, number 5. We have positive charge at carbon number 6. Okay, we have the hydrogen here, and then we have the CH3. The final step will be the regeneration of catalyst, where we're going to take the nucleophile in this case, which is AlCl4, in this case, the negative charge will attract the hydrogen, while the bonding between the hydrogen and the benzene will attract it to the positive charge. So it will produces the benzene, okay, double bond at number 1, number 6, number 2, number 3, and number 4, number 5. Right, the CH3 will remain at the ring, while the hydrogen will combine with the AlCl4 negative. Since the hydrogen loses its electron, it will have the positive charge. If we take a look at the side product, okay, this structure will rearrange and then it will produce HCl plus AlCl3, and please take note that AlCl3 is the initial catalyst that we have used. So there you have it. These are the 3 things that we need to show. Again, the first one is on the generation of the electrophile. Secondly is the exchanging process of the electrophile with the hydrogen. And finally, we're going to get our desired product while producing back the early catalyst that we are using. Here's another question related to the mechanism of the electrophilic substitution reaction. So this was taken from the tutorial, so we try to answer question 3A. So just like the previous question, okay, the keyword here, you can see that the stepwise mechanism of the nitration of toluene to form 4-nitrotoluene via the electrophilic substitution reaction. So what we need to do is, first and foremost, we need to come up with the general equation. We read back again the question. Show the stepwise mechanism of the nitration of toluene. As you can see here, the process of nitration, we already knew that it is comprises of nitric acid catalyzed by sulfuric acid. But only this time, we are not dealing with unsaturated benzene. In this case, we're going to use toluene, which technically having CH3 attached to the benzene ring. So the process is, we're going to add the NO2 electrophile into the ring. And then it also mentioned that this reaction will produce 4-nitrotoluene. Although you can see here the CH3 is an orthopara, we only need to show the formation of the para-nitrotoluene of 4-nitrotoluene, which means that the structure should be looking like this. The NO2 will be specifically replacing the hydrogen from carbon number 4, because the question has specifically asked for the nitro to go to the to proceed with this configuration. If your answer replacing the hydrogen from carbon number 2, then technically this will be incorrect. Okay, so okay, I just delete back, I just clear back the screen a little bit, and then don't forget the side product of will produce the water molecules. So let's take a look on how do we write down the mechanism for this reaction. Again, I would like to remind that for this question, we're going to start off from toluene and we're going to show the nitration process, meaning that you cannot use unsubstituted benzene. We're going to use the toluene as our benzene derivative. So the first step is, Again, we're going to generate the electrophile. So, electrophile will be produced from the reaction between the reactant and also the catalyst. So, in this case, we have nitric acid together with sulfuric acid, and then the nucleophile, the electrophile that we're going to produce here will be NO2, and don't forget the symbol plus because it is a electrophile. Again, I want to remind that electrophile stands for species which attract to the electron. Electron is negative, therefore electrophile must be positively charged because positive always attracted to the negative. After we generated the electrophile, we also going to produce a nucleophile, which is negatively charged, which coming out from the sulfuric acid. One of the H has been eliminated, so it's going to become HSO4 negative. The H, which had already been eliminated, will produce water. It's come from this hydrogen, it's coming out from the sulfuric acid just now, and then it's going to attach to OH coming out from the nitric acid. That's why we're going to get the water molecule. So this is the first step where we obtain our electrophile and we obtain our nucleophile that will be used in the next step. So the second step is the attacking process of the benzene towards the electrophile. So after we have produced our electrophile just now, the benzene, alright, in this case, okay, we're going to use toluene because the question already stated that it started from toluene. So we just draw back the structure. Okay, we just draw the structure of the toluene. And then to show the mechanism, it's better for us to draw the conjugated calculate structure of the benzene with the conjugated double bond. So our aim is we're going to replace the hydrogen from carbon number 4. Okay, kenapa kat carbon number 4? Because the question has specifically stated that it must form 4 nitrotoluene. So in this case, if we label the number, if we label the benzene, the hydrogen is located at carbon number 4. So the double bond which is positioned at carbon number 3 and number 4 will be affected. Okay, we know that this double bond is consists of 2 electrons. So what's going to happen is the bonding will be broken because it's going to attack the electrophile that has been produced, which is the NO2 plus. So since the electron is negatively charged, it will be attracted to the NO2. It will produce this intermediate. Okay, we just draw back CH3. Alright, number 1 and number 2 double bond will remain the same. Same goes with the 5 and 6. Number 4, okay, will break its bond with the carbon number 3, and then it will attach to the NO2, and then the H will also attach to the same carbon. Carbon number 3 just now has lost its electron, so it has become more positive. That's why it's going to have a positive charge at the carbon number 3. Just like the previous question, what's going to happen is the nearby electron, which is positioned between carbon number 1 and number 2, it is also an electron here, consists of 2 electrons. It will attracted to the positive charge because again, negative and positive will attract each other. So it's going to form an intermediate. So the intermediate was, okay, the benzene. Okay, we just draw back the structure. CH3 will remain the same. The hydrogen and also the NO2 will remain the same. And then double bond between carbon number 5 and 6 and newly formed double bond at 3 and 4 will be formed, while, okay, I'm sorry, okay, it's supposed to be, since number 1 and number 2, number 1 and number 2 will transfer to number 2 and number 3. So what will happen is, number 1 has lost its electron, so it will become more positive. So the positive charge has been transferred to the first carbon. And finally, this process, it will attract the bonding from number 5 and number 6 to number 1 and number 6. Okay, because again, the negative charge will attracted to the positive charge. So we draw back again the structure. We have the CH3, we have the H and also the NO2. And finally, we have the double bond between carbon number 1 and number 3. Number 6 and number 1. And since number 5 has lost its electron, it will have the positive charge. So if we combine all of these three intermediate, okay, we can simplify the structure as this. Okay, we have the benzene ring, we have the CH3, and then we have the H and also the NO2, while inside the ring, okay, we have the positive charge that is being delocalized inside the benzene ring. So this is the stable structure of the intermediate that has been formed. Right? Technically, if you're going to draw the end product bond, it's okay, but you should know that it can form whether structure A, structure B, or structure C intermediate. Okay, but the main structure will be structure A. Okay, last but not least, we're going to use the structure A to form the final step, which is regenerate the catalyst. Okay, again, the catalyst in this reaction was sulfuric acid. So for the final reaction, we just take the structure from A. Okay, I just draw back the structure of A. Okay, the structure of A comprises of the benzene ring. Okay, with CH3, and then we have H and also NO2, and then we have a double bond position at the first and second carbon and number 5 and number 6. In order to perform these steps, okay, we need to have our nucleophile that we have produced earlier. Okay, I just show back again. Okay, for the first equation just now, for the first equation now, this is our nucleophile. So what's going to happen is, again, the negative charge will attract the hydrogen, which have the tendencies to be electropositive, and then, okay, there is positive charge here. So the bonding between the carbon and also the hydrogen will attract to the positive charge. So when the sulfuric acid taken the hydrogen, okay, the compound are going to produce is the H2SO4, which is the initial catalyst, plus our main product, which is the benzene ring with the CH3, and then the double bond existed between carbon number 1, number 2, number 3, number 4, and number 5, number 6, and of course we have NO2, which has been replacing the H. I would like to remind you again that, highlight again that the hydrogen has combined with the HSO4 negative to form our catalyst bed, which is sulfuric acid, and then we get our derived product, which is the 4-nitro-toluene. So there you have it. Okay, these are the steps, okay, that is required in order to show the mechanism of the electrophilic substitution reaction. Try to do similar question related to these topics to test your understanding. Okay, if you have any question, please leave a comment below or just ask in the Telegram group. Okay, that's all for this video. Okay, goodbye.